Welcome to Brain Vision.
So in this problem, we want to compute the probability that the hydrogen atom of a 1s electron will be found somewhere in the range between r equal to 0 and r equal to a naught. So first of all, let's remember that the wave function of the hydrogen atom is given by the NLM quantum numbers, and that for the 1s electron, this corresponds to 1, 0, 0 wave function, which is 1 over pi, the square root of pi a naught to the cube times the exponential of minus r over a naught. And let's recall that to find the probability to find an electron in between two places, we need to perform the integration over space between the space that we require. In this case, is from 0, let me put in red, is from 0 to a naught of the square root of the wave function. In this case, we need to include the Jacobian because we're dealing with spherical coordinates instead of Cartesian ones. So we need to take into account the transformation of coordinates through this Jacobian. So we can take directly the square of the wave function, which gives us this result, and our probability will become finding the integral for the following result, which is just replacing the value for the phi 100 probability distribution function, which is the square root of my wave function, yielding pi and pi cancel out, and here we're going to get 4 over a naught cube, the integral from 0 to a naught of the exponential of minus 2r divided by a naught times r squared dr. So now the problem is just how to solve this integral. So first of all, we're going to do the following substitution. Let's make x equal to 2r divided by a naught. With this, we're going to find that the value for r is equal to a naught x over 2. And we can do directly that dx is equal to 2 over a naught times dr. Or, as well, that dr is equal to a naught over 2 dx. So we can replace these values directly in our integration. Let's go ahead with our probabilities, and we're going to do the integration in terms of x instead of r. So we need to replace the limits. For example, what is the value for x when r is equal to a naught? What is going to happen is that x is equal to 2 times a naught over a naught, so x is equal to 2. And at r equal to 0, x is going to be equal to 0. So whenever we do this change of variable, the limits of integration change from 0 to a naught to 0 to 2. So now the integral that I want to solve will become the integration from 0 to 2 of 4 times, instead of writing down my r squared, I'm going to write down the value here of a0x over 2, 4 times a0x over 2 squared divided by a0 to the cube times the exponential of minus x times dr, that we said that was a0 over 2 times dx. Now let's expand this a little bit and see what we can cancel and what we cannot. This is the integral from 0 to 2 of 4 times a0 squared x squared divided by 4, 4 and 4 cancel out, divided by a0 cubed times the exponential of minus x of a0 over 2 dx. As you can see, a0 squared times a0 is going to give us a0 cubed, and this is going to cancel out each other. So this becomes a0 cubed times x squared divided by 2 times a0 cubed times e to the minus x dx. So now the integral that I need to solve, of course here integral from 0 to 2, becomes the integral from 0 to 2 of x squared e to the minus x divided by 2 dx. This integration can be done by parts, and the result is going to be equal to 1/2 of e to the minus x let me put here my big parentheses, e to the minus x times the following polynomial, that is minus x squared minus 2x minus 2. And all of this is going to be evaluated from 0 to 2. So now the only thing that we need to do is replace the values for 2 and 0. So this is equal to 1/2 e to the minus 2 times minus x squared, so this is minus 4, minus 2 times 2, which is 4, minus 2, minus the value at 0. So e to the minus 0 is equal to 1 times 0 minus 0 minus 2. This gives us minus 6 e to the minus 2 over 2 minus 1, which turns into 1, which is, sorry, here a little typo, not 6. This is going to be 10, minus 10, of course, which is equal to 1 minus 5 times e squared, e to the minus 2, which gives us a 0.3233 value for probability, which corresponds to a 32.33%. So with that, it will be all. Thank you very much and have a good one.